Okay, so what we're going to look at here is how the resistance of this thermistor changes with temperature. Now, the thermistor is made out of a semiconductor. So here we're not talking about the same number of free charge carriers as you'd have in a metal, nor are we talking like an insulator where you have pretty much zero free charge carriers. We're talking about a number of free charge carriers that's very intermediate in the middle. These semiconductors are usually based on silicon, and what I'm going to do to measure the resistance is just use one multimeter set to measure resistance. Now at the moment it's reading 1 spaces and then a point. That means that the resistance is pretty much infinite. If I touch the two together, then what should happen is I should get a low resistance. Like this, okay. So, 2 crocodile clips attached, one to each side. I'm heating up water. Whoop. Right, I've got some very hot water here, which we'll look at in a second. Now, if I put this into water, what I'm probably going to be reading is the resistance of the water between these 2 points. So what I'm going to do is I'm going to take a bit of a latex glove, cut off the tip. I'm going to pop my thermistor inside latex glove like this, so that when I take a reading, the reading I'm taking is the resistance of the thermistor and not of the water. Now, the water is really nice and hot. Okay, and ideally what I would do here is I would have a stirring thermometer, and I would make sure that the thermometer and the thermistor are both in the water close together, not touching, and that I stir the water thoroughly to make sure the thermistor, the thermometer and the water are all at the same temperature. But as soon as I'm a little bit limited here, I'm going to use my infrared thermometer. So I've got 0.54 kilo-ohms and the temperature is 64 degrees. Now, the easiest thing is to have hot water and to go cooling it down. lot less trouble than having cool water heating up and having a heat source here as well. So let's stir up this water. Make sure the thermistor is there in the water. Now temperature is 54 degrees and I've got 1.45 kilo-ohms. Just popped a bit more cold in the glass. Stir up the water a bit. No, now I've got 52 degrees, 51 degrees Celsius, 1.72 kilo-ohms. Cool down a little bit more. Stir up the water. Now we're at 40 degrees. And we're going above, what are we? No, 2.71 kilo-ohms. Now we're down to 33 degrees, 3.75 kilo-ohms. Now go for a full glass of cold water from the tap. Oi, that was good. Cut off another one. Okay. Twenty 24 degrees, 5 kilo-ohms. So what we need is pop that into a table to plot a graph, and part of what we're going to be thinking about here is how could I increase the range of temperatures and improve on this experiment to get a bigger range of data. And later on, once we finish writing this up and plotting the graph, we'll come to a conclusion about why the thermistor behaves as it does. Why, as the temperature decreases, does the resistance increase? Because that is a bit different to what we've come across so far. But these are things for us to talk about.